today we're continuing with the chain rule. We're just taking the derivatives of more complicated functions. So first thing is you can use the chain rule and the product or quotient rule simultaneously. So in our first example, y is equal to x squared times x minus 3 to the 5th power. So if you notice, this is a product. Here's my first term, here's my second term. So I'm going to use the product rule and the chain rule in order to take the derivative. So product rule says take the first term, don't change it, and then you take the derivative of the second. So I'm going to pull my exponent out front, keep the insides the same, subtract 1 from my exponent, and then multiply by the derivative of what's inside the parentheses, which is 1. First times the derivative of the second plus the second times the derivative of the first, which would be 2x. So now I'm just going to clean this up a little bit. This is 5x squared times x minus 3 to the 4th plus 2x times x minus 3 to the 5th. So if you notice, I have an x and an x in each of these terms, and x minus 3 to the 4th in both of these, because x minus 3 to the 5th is x minus 3 to the 4th times x minus 3. So I can factor out a x and an x minus 3 to the 4th power from both of these terms. I'm going to pull out an x, and I'm going to pull out an x minus 3 to the 4th. So, when I pull out an x and x minus 3 to the 4th, I'm left with the 5 and one of the x's. When I pulled out the x and x minus 3 to the 4th, I still have the 2 left over. And I had an x minus 3 left over. Since x minus 3 to the 4th times x minus 3 is x minus 3 to the 5th. And so now, I'm left with x times x minus 3 to the 4th times 5x plus 2x is 7x. And distribute that 2 to get minus 6. So if the directions ever say to factor it completely, this is what it's wanting you to do. Look for common terms in both of these and factor them out. Try this one on your own. Pause your video, copy it down, attempt it on your own. Take the derivative. Alright, so this is product rule. So I have two terms. So first times the derivative of the second, I'm going to use the chain rule. Pull my exponent out front. Keep the insides the same. Subtract 1 from my exponent, and then I have to multiply by the derivative of what's inside the parentheses, which would be 2. First times the derivative of the second plus the second times the derivative of the first, which would be 6x. And so now, I'm just going to say 3 times 4 is 12. 12 times 2 is 24. X squared times 2x minus 1 to the 3rd plus 6x times 2x minus 1 to the 4th. So now I want to try and factor that completely. I see that I can take out a 6 from 24 and a 6 out of 6. I can take an x out, and I can take a 2x minus 1 to the 3rd. Since I have 3 over here and 4 over here, I can take 3 out of both of them. So now, when I think about what's left over, I took out the 6, so I have a 4 left over. I took out an x, so I have an x left over. Took out all of those, that's good. Then on this one, I took out the 6, I took out the x, but I still have one more 2x minus 1 left over. So my final answer is 6x times 2x minus 1 to the third times 6x minus 1. That's your final answer, factored completely. Next example, f of x equals x to the third times the square root of 1 plus x squared. So, first thing I'm going to do is rewrite this. I'm taking the square root of the whole thing, so I can rewrite it as all of that raised to the 1/2 power, since I'm taking the square root of it. And so now, this is a product. Here's my first term, here's my second term. I can use the product rule and the chain rule simultaneously. Product rule first times the derivative of the second. So I'm going to take my exponent, pull it out front, keep the insides the same, subtract 1 from my exponent. 1/2 minus 1 is negative 1/2. And then I have to multiply by the derivative of what's inside my parentheses, which in this case is 2x. Oh, I used a bracket, but it can just be another parenthesis. First times the derivative of the second plus the second times the derivative of the first, which would be 3x squared. So now I am going to have x to the third times 2x times 1/2. The 1/2 and the 2 cancel out, so it's just x to the fourth. And then I need to send this to the denominator because I have a negative exponent, so all over 1 plus x squared to the 1/2 plus 3x squared times 1 plus x squared to the 1/2. That's your final answer. Alright, and then the last one, f of x equals x over the cubed root of x squared minus 2. First thing you're going to do is rewrite this so that it's x over x squared minus 2 to the 1/3. So you could do the quotient rule, low d high minus high d low all over low squared. That would be totally fine. I think it's actually easier though, instead of doing that, to now take x squared minus 2 to the 1/3 out of your denominator, move it up into the numerator by making it a negative exponent. I think that's going to make it a lot easier, and so now we can use the product rule and the chain rule simultaneously. First, which is x, times the derivative of the second. I'm going to use the chain rule. Take my exponent, pull it out front. Keep my insides the same. Subtract 1 from your exponent. Negative 1/3 minus 1 is negative 4/3. And then you have to multiply by what's inside the parentheses, which would be 2x. Multiply by the derivative of what's inside the parentheses. I'm sorry. First, times the derivative of the second, plus the second times the derivative of the first, which derivative of x is just 1. So now I can just clean this up a little bit. F prime of x is this x and the 2 would make 2x squared, and there's a negative. The 3 is in the denominator, and I'm left with all this, but it has a negative exponent, so I'm just going to send it to the denominator in order to make that negative exponent become a positive exponent. So the x became 2x, or became x squared, then the 2 and the negative are all in the numerator. The 3 went down to the denominator, and then all of this went down to the denominator as well. And then I just need to do plus 1 over, send all that to the denominator, x squared minus 2 to the 1/3. And you are done. That's your final answer.